Okay, so now we come to the last question for this paper, question number 7. We are having the length of 150 fish of a certain species. And then the length correct to the nearest centimeter are summarized in the following table. So this is the table that we have. They are talking about the length. Okay, so they want to draw a cumulative frequency graph to illustrate the data. Okay, so to draw the cumulative frequency graph, right, our y-axis should be the cumulative frequency. And for our x-axis, it should be at the upper class boundary. Okay, so I need to maybe try to create a simple table, okay, to list out the upper class boundary, okay, and also the cumulative frequency. Okay, so maybe this is a table that I want to form. Okay, so how can I get the upper class boundary? Okay, so for upper class boundary, I need to know, okay, what is the class boundary for every single class here. Alright, so we should start from 0, of course. Okay, so we should start from 0. So the first class is always start from smaller than 0 and the cumulative frequency is 0. Okay, because there's no frequency yet. And then you can see that there's a gap between the 9 and also the 10, right? So I have to adjust it become the class boundary. So the center of 9 and 10 will be 9.5. So my upper class boundary for the first class is smaller than 9.5. And the first frequency that I have is 15. So I just put it as 15. So that means there are 15 fish. The length is smaller than 9.5 cm. Okay, then after that for the second class, what's the upper class boundary? So 14 and 15, there's a gap, right? So you take the value in between. So it'll be 14.5. So for smaller than 14.5, the cumulative frequency is, please take 15 plus 48. So 15 plus 48, you should get 63. Same thing happen for the next class. Okay, upper class interval is 19, but there's a gap between these two classes, so you have to adjust the value, become 19.5. And for the cumulative frequency, please add your answer 63 just now with 66. So you should get 129. Then same thing happened for the last class, because all the class here you have to add 0.5, right? For the upper class boundary. So for the 30 also you have to add 0.5, so you get 30.5. And for the last cumulative frequency, you add 21 with 129. So you have 150. Okay, so basically this is a simple diagram, the simple value that I need to know, where all the upper class boundary here will be my x coordinate, and then the cumulative frequency here will be my y coordinate. Okay, so you need to maybe try to get a volume, get the ratio that can fit inside this graph paper provided. Okay, so for the cumulative frequency, right, for the upper class boundary is from 0 until 30.5. So what I want to do is like, I'll make it start from 0 here. Then every single 2 cm will be 5, 10, 15, 20, 25, then 30. And it is enough for me to put in 30.5. So I need to label it. This is the length in cm. Okay, then for my y-axis, the label for y-axis should be cumulative frequency. So don't forget about the label first. Okay, my cumulative frequency is from 0 until 150. That means maybe I can put 20 units for every 2 cm. So 40, 60, 80, 100, 120, then 140. Okay, alright, so after I decided my ratio, okay, and also label all my y and x axis, then I can start plotting the graph. Okay, so by using the information I have in the table, so start from 0, 0. Start from 0, 0. Then 9.5 is 15. So 9.5 is 15. So maybe 15 is somewhere here. Okay. Then 14.5 is 63. So 63 might be somewhere here. This is 70, right? So 63 might be somewhere here with the 14.5. So you have to try to measure your ratio correctly. Huh? Then 19.5 is 129, so it should be somewhere here. Then for 30.5. Okay, so 30.5, what do I have is somewhere at this part, 30.5, right? Okay, wait, let me count it first. So for my ratio that I use, you have to make sure that you count it correctly. Sorry, this one should be 19.5 on the line. This one also on the line. So 30.5, it will be on the line as well. Then 150, right? So this one. Okay, then of course my graph will not be very accurate. So please make sure that you measure your graph correctly in the graph paper, and then try to sketch it as smooth as possible by joining all the points together. Okay, so this is what I get for a cumulative frequency graph. All right. So make sure you plot the point correctly. Make sure you measure the ratio clearly, okay, with a consistent ratio, right? So that your graph looks normal, okay. Looks correctly. Okay, so this is what you have for part A. Okay, how to sketch a cumulative frequency curve. And now we continue to part number B. They are saying that 40% of the fish have a length of dcm or more. So use your graph to estimate the value of D. Okay, so you know that 40% you are having dcm or more. But for all the cumulative frequency curve that we draw, right, we are actually measuring less than value. So when you're having DC more than or equals to dcm, right, basically we cannot estimate it directly. We have to change it into the meaning of less than dcm. So how many percent is having the length less than dcm? 40% is having the dcm or more, so 60% will having less than dcm, right? So when you want to estimate the value, you have to use a 60% value from the cumulative frequency curve. So 60 divided by 100, which is 60%, multiply with the total frequency, you should have value 90. Which means that if you want to know the dcm, right, you should estimate the value from the 90. Okay, using the 60% but not the 40%. Okay, so please remember that when you are using the cumulative frequency curve to estimate any value, please make sure that you change your question into the meaning with less than but not more than. Alright, so for 90, the frequency 90, right, to estimate the value, you have a look where is your 90 here. So please label it clearly on your graph, 90, and then you try to estimate it by drawing a line to touch your curve, and then read the value from the x-axis, which is the length. Okay, so if your ratio is good enough, right, and your graph is clear, by right you should get the value more or less at this value, like 16.5 or 16.25 or maybe 16.75, more or less at this value. Okay, all right, so after you estimate it clearly, then you just write out your answer here, and then the D is equals to 16.5. This is the answer from my diagram. Right, so if you use your own diagram, you might have some slightly different value, but by right it shouldn't be too far away from this. Okay, and then just a reminder, please make sure that in your graph, you draw the line 90, the estimation line 90 correctly, clearly in your graph to show them how you estimate the value. Okay, right, so this is how we solve for part number B. And let's continue to part C. For part C, they tell us that the mean length is 15.295. They want us to calculate the variance. Okay, so to calculate the variance, right, we need to find out the midpoint. Okay, the variance formula is actually like this. Summation of fx squared divided by summation of f, then minus the mean squared. So x is the midpoint. Okay, frequency, f means frequency I have. So I need to find out all the midpoint first. Okay, so for this question, there's a small part that we need to be very, very careful. Okay, so we are having 0 until 9, right? And then we are having 10 until 14. Okay, then after that we are having 15 until 19. Okay, if I want to know the class boundary, we will look at the border of the class interval, right? So if let's say this one is 14, this one is 15, 14 and 15, there's a gap, so the upper class boundary will become 14.5. Same thing happened here, 9 and also 10, right? So there's a gap between 9 and 10. So that means for this class boundary, you need to adjust it become 9.5 to 14.5. Then this one is 14.5 to 19.5. Okay, and same thing happened for the last class. And then to get the midpoint, we are using the class boundary, right? So to use the midpoint, basically, okay, so you are taking 9.5 plus 14.5 divided by 2. So 9.5 plus 14.5 divided by 2, by right, you should get a 12. Then for this one, 14.5 plus 19.5 divided by 2, and you will get 17. Okay, then same thing happen for the last class. You're having 20 to 30. 20 to 30, right? If I'm not mistaken. So 20 to 30. Okay, so for 20 to 30, if you add them together, 20 plus, there's a gap, 19 and also 20, right? So for adjustment, you should have 19.5 to 30.5. So for the midpoint, you are taking 19.5 plus 30.5, then divided by 2, and you should get a 25. Okay, alright, so basically this is how you calculate the midpoint. But there's a small problem here for the first class. Okay, so for this first class, right, if you have a look, you actually can see that we are having a value start from 0. So this is something that you need to be very, very careful. Okay, when you have the grouping of class interval that start from 0, you need to take note on this. Okay, where if you are having a continuous random variable, okay, when you want to adjust your class boundary, it cannot be a negative value. So that means this one, the 0 cannot minus 0.5. It should be starting from 0 until 9.5. But if your data is a discrete random variable, then when you're having the grouping start with 0, and if you want to adjust it, become the class boundary, right, you can minus 0.5. So 0 minus 0.5, you get negative 0.5 until 9.5. Okay, so what's the reason behind? So the reason behind is, it is because of for continuous random variable, usually we are measuring them like weight, length, alright, or we take time. Okay, so all these are measured or we weight them. Therefore, all this data usually will be positive, it cannot be negative. Okay, but for discrete data, okay, for some point, it is possible that we are having a negative value for x in discrete data. Therefore, the negative 0.5 is allowed. Okay, so for this particular question, we are having length, right? So length is actually a continuous random variable. Okay, it's a continuous random variable. Therefore, when you are having the class boundary for this first grouping here, it should be 0 until 9.5. It cannot be negative 0.5. So the midpoint will be taken as 0 plus 9.5 divided by 2, and you get 4.75. Okay, so to me, this is a special part that you need to be very careful. Okay, because I believe that quite a number of students, they are not aware of this. Alright, so when you're having the grouping start with 0, so there's a small part that you need to take note of. Okay, so this is a length, which is a continuous random variable. Therefore, it cannot be negative value. So the 0 cannot be adjusted, become negative 0.5. We should remain it as a 0. So our midpoint is affected, which is 4.75 here. Alright, so let's come back to our variance. So after I get ready with all the value, all the midpoint that I want, so I will calculate the variance. So the formula for variance is this one. So f multiplied with x squared. So frequency. So what's the frequency for first class? Is 15. Okay. then multiply with x. X is the midpoint, 4.75, and then square. The frequency, you get it from the original table given at the beginning of the question, yeah. Okay, so 15 multiply with x squared. Then after that, what is the second value? Maybe I write here, it's easier. It's more spacious. Okay, so 15 multiply with x and then square. For the second class, the frequency is 48. Then the midpoint is 12, right? So midpoint is 12. This is the x, and then you need to square it. Then the third class, frequency is 66. Midpoint is 17, which is the x, and then you need to square it also. Lastly is 21 frequency, and then I'm having midpoint 25, which is the x, and then you need to square it. So what is the total for the frequency? Total of the frequency will be 150, then minus the mean. Mean is given already in the question just now, which is 15.295. And then you square it. Okay, so by simplifying this answer, you should have 39449.4375 divided by 150 minus the mean square. Then you'll get the long decimal number 29.059225. And of course, you cannot leave your answer like this. You have to correct it to 3 significant figure. So by right, your answer should be 29.1. Okay? Yeah, so this is how we solve this question. So please take note on the grouping, okay, that is always start from 0. So take note on this part. There's a small difference between continuous and also the discrete data. Alright, so we have finished discussing all the questions in this paper. Thank you very much for watching.